So there it is. Now, is this my answer? I've seen that before too. You know, you did so much mathematics, you're like, I'm done. Because you knew you needed the normal vector. You're like, wait, I never wrote the what? Equation. How do we write this equation? We set it up as, you ready? We need this thing. That's sitting right here, right? How do we write the equation of a plane? It's always 4 times something plus 0 times something plus -4 times, and then what's it all equal to? 0. Let me get this answer ready. What goes into parentheses though? See, oh, I love it. Choose the points. And I do x minus, y minus, and z minus. Is it always a minus? Yes, because we said with vectors you always do tip minus tail, right? Yeah. So this would be the x minus, now which point do you want to use?
Choose the first one.
Let's use the first one. It doesn't matter which point you use, I want you to use a p. So x minus a
6.
Y minus a, hey, how do you want to make that?
Plus.
And when you can make that a plus 11. And then z minus equals,
0.
0.
and you're done. And I'm going to make that a plus, okay everyone?
You don't want us to,
You don't have to.
because when the whole y factor disappeared from my plane.
I mean, you can totally do it if you want.
Okay.
And what's so cool about planes is these coefficients, the x, y's, and z's, have to be the what?
0.
The normal vector. Or at least some scalar multiple of the normal vector. Cool? It's just a nice check. Awesome. Hey, we'll now do 12-6. I just want to make sure. Oh, then wait. We'll do 12. There's one more problem I want to do. And when this is like the last problem on this practice set. There's a problem in the textbook like this. So I want to give it to you. Planes. Now we know how to get the equation of a plane, right? How can we tell if 2 planes in space are parallel or perpendicular? That's what we're going to write. So can I erase this? Now you all notice these numbers in front of the x, y's, and z's, they represent the normal vector, right? Okay. That's key. Well, how do you know if 2 planes are parallel? Or are they perpendicular? Or the other answer would be neither. Now, hey, this is like the last problem in the practice set. This is also like section 12.5. I know I signed some of these, I want just to practice. This is like number 51, 53. So let me make a plane up. Watch how I'm going to make up planes. 2x plus 5y minus z equals, this doesn't always have to equal 0 though, does it, if I got everything distributed? So I'm going to just make that like 11. That's one plane. Now let me make up another plane. I'm making these up. Okay. 6x minus y plus 7 equals, how about 23? Now those are 2 equations of planes. Do you all agree? Can you tell me? You know, the x, the y, the z, there's numbers in front of them just like we had before. Our question is, we got to determine whether these 2 planes, this is one plane, this is another plane, are they parallel, are they perpendicular, are they neither? Well, let's start with perpendicular planes. I don't know. I can go like this. Well, then this has a normal vector going like that. And this thing has a normal vector going like that. What do you think would have to be going on with those 2 vectors, those normal vectors?
Parallel.
If the 2 planes are like this. I think I'll use my folders because you'll see it. And when I get a vector like this, here's a plane, and here's a plane, right? Now if they're perpendicular, it's something like this, do you agree?
Yeah.
Absolutely. Well, where's the normal vector going off that green folder?
Up.
And
Up.
the other plane.
Where's the vector going off this sheet?
This towards us.
It's going out. What do you think has to be going off those two
Also,
vectors?
they will be
Something's
normal.
going on with them.
They are normal, right, to each other.
Very good. What
And
would
they-
be their
and
dot product?
0.
There it is. That's what we're gonna do. To determine whether or not, I love it, man. To determine whether or not two planes are perpendicular to each other, the dot product would equal what?
0.
0. So that would be for this. That's what we're gonna check. Now, if the dot product's not equal to 0, then they're not perpendicular. How are we gonna know if they're parallel? Because parallel planes, everyone, just go like this, right? Should have another better folder there. And this will do. You know, you go, what's going on with these? That just means everyone, the normal vectors are running in the same direction. Do you agree? That means the normal vectors, each one of those vectors that are normal to planes, have to be scalar multiples of each other. So what we'll do is, to determine whether or not they're parallel, we're just going to look at this, the ratios, to make sure they're all equivalent in front of the x, y, and z. So I'm going to put down the word check the ratios. Make sure all the ratios, this over this must equal this over this, must equal that over that, and that would mean they're all what? Parallel. Cool? Now, do you have to do the ratio of 11 and 23? Would you have to check that ratio? No, because where's the normal vectors? They're always the coefficients to the what? The x and the y and the z, right everyone? So that when I say check ratios, I mean just look in front of these and make sure they're all equal. So first of all, are these planes parallel? No way, because is 2, 6 equal to a 5 over negative 1? What do y'all think? No. Right? Plus it would have to equal the what? The negative 1. I mean, are these equal?
No.
Then it's not what? Definitely not parallel planes. But are they perpendicular? If neither of these hold, then we gotta say neither. Evan, what would be the dot product of the normal vectors? Do you see it? 2 times a what?
6.
Plus.
5 times negative 1.
Plus.
Negative 1 times 7.
And don't do these. Remember we said that? What do you get? What's the answer?
Perpendicular.
I'll give you one more. How about that? 99, 102. I do this for emphasis, everyone. We don't what?
We don't care
We
about
don't even care about those when we come up to these questions. We're just looking at what's going on with these normal vectors to the planes. Are they parallel, perpendicular, 0? Well, let me check the dot product real quick. 12 plus 75 plus 3. No, that's not 0.
0.
And they're parallel. Because what's going on with these ratios?
The same 1/3.
2, 6 is equivalent to negative 5 over a negative 15, which is equivalent to a, and when these would be parallel. The two planes are parallel. Cool. Now what if neither of those hold?
Then neither.
Neither. Okay, rest of class, we get to do 12.6. Now this is fun. Now, I think I missed a couple people. I'm just going to bring you a sheet. This is fun. This is the cylinders and quadric surfaces. I want to get chalk on this. Here you go. Who else didn't get a copy? Oh, here you go. One of those things is in the textbook, but it just gives a copy of the cylinders. So we're going to draw some cylinders and quadric surfaces in three-dimensional space. This is fun, because all the sketches you did before this haven't been too bad. I mean, like I said, we're going to sketch things like this.
What's this section called?
This is titled, for 12.6, surfaces. Now I'm going to write that on the board. They actually title it cylinders and surfaces. Get there. Cylinders and quadric surfaces. You see that title? But I am just going to put the word surfaces here for now, because a cylinder really is a surface. All right. And when you think of a trash can, that's a cylinder. Think of a trash can. Is there a surface to that?
Mm-hmm.
Yeah. So I mean that's a surface too. Like cylinders are very specific, so I'll make sure you understand that in notes. But we can just title this what? Surfaces, right? So by me just titling it surfaces, well, heck, isn't that a plane? I just want y'all to look at that. Did I just give you an equation of a plane?
Yes.
There's no x squareds or y squareds or z squareds in there, right? That's the equation of a plane. How would you sketch a plane? Now, I'll be honest, this question isn't asked in 12.6. This is asked in 12.5. I just thought I would show it to you now. And when they want us to sketch this plane. All right, I think the easiest way is using intercepts. Will that work? So can we use intercepts?
Mhm.
Now, what would be an x-intercept? The y and a z would have to be what?
0.
So would you make those zeros? So hide that. What would have to be the x value of a point on that plane? 4. Anyone see that? We'll find the 3 intercepts and plot them in that thing and we'll be done. We'll connect them. It's gonna look like a triangle, but it would be a sketch. All right, how about a y-intercept? Y-intercept, the z and the what? X is 0. All right, what's y?
2.
2. We need one more point. How about the z-intercept?
8.
That would mean this is a 0 and this is a 0. Let me hide those. What is it?
8.
Well, what would this plane look like? Go up 8 notches, put a dot. Go over 2 notches, put a dot. And then go down this x-axis, everyone. Put a dot, and then just do what? I know it looks like a triangle, but this triangle would go on what? Infinitely? Yeah, we just got an idea of this slanted. It's got that slant there. Chapter 15, everyone will form a tetrahedron out of this thing and find a volume. It's fun. We just do, remember integrals? Calc 1? Integrals in Calc 2? We just do double and triple integrals. Is it hard? No. You just do the integral twice. It's not hard at all. But that's how we'll find, like, get the volume of the tetrahedron formed by this. But to get it started, you're going to have to draw a picture. Does that make sense? Well, that's a plane. But how about cylinders? So let's start with cylinders first. Cylinders, everyone, would you make a note? You're going to only see 2 variables. You will only see 2 variables.
So no
2 letters. If you don't like the word variables, 2 letters. Here's an example. And when you and I are going to sketch this in 3 space. Now I have to emphasize, everyone, I'm saying 3-dimensional space. Because look what I'm writing. X squared plus y squared equals 4. And when if you think about it, if I didn't say in 3-dimensional space, if I wasn't specific about that, I think you all are thinking about a circle, aren't you?
Mhm.
That's the equation of a circle in 2-dimensional space. So I do have to be very clear when I ask you to do this. I would have to say, would you make this sketch in what? 3-dimensional space. But do you notice how many letters there are?
2.
That's when you know you got a cylinder. Okay? Whoops. I can't say it's always the case because the plane, what if one of the coefficients to the plane is 0? Then you only have 2 letters. But usually when you see these 2 letters, you're thinking, oh, this is a cylinder. Okay? So now we're going to sketch this. It's not a circle? No, because it's in 3-dimensional space. Well, what letter's missing?
Z.
Would you make a note about this? That means Z is anything. That's what it means. Z can take on any value. That's what it means in 3 space. It doesn't mean it equals 0. It could be 0. But Z can be any value, is what we're saying. X and Y have to hold true in this relationship. But Z can take on what?
Any value.
Any value.
Will you always be given X and Y? Can you be given X and Z?
Oh, I'll do that one next. I love her question. She goes, what if you're given X and Z? We'll do that one right after this. So I thought I would start with this. You're given X and Y, and isn't that, we're thinking like a circle, right? What would be the radius?
2.
2, and then here's the x-axis. Here's the y-axis. and there's the z-axis. So when I'm thinking, okay, I could just make a circle here with a radius of 2, right? No one see it?
Uh-huh.
But what letter was missing?
Z.
So I said z could be anything. So can you get an idea of what this is going to form? Because infinitely I can make these circles this way. Because z can take on any value. And what's it turn into?
Cylinder.
A cylinder. And where's this cylinder centered?
Zero.
Yeah, around the z-axis. Let me make sure, I want to center that thing. Don't get it right smack dab in the middle, right? It'll be centered right on that z-axis. I think that's far enough. Would this just keep going forever?
Uh-huh.
If you want to put words down, you can say the radius is 2. It's the same. Now, but when I'm talking about the surface, I'm talking about all the points on the what? On the edge of the surface. That's what I'm pointing out. All the points that are sitting on the surface. What about the top? Well, this went on infinitely. There is no top. True? Now, if you're like, yeah, but I want to talk about all the points inside of it. Oh, all you have to do is go up here and go like that. I'm going to erase that, but do you agree?
Uh-huh.
Now you're talking about everything on the surface and what? Inside of it. You just filled it up with like water. But right now I'm just talking about the points on the surface. So now I'm going to your point. Let's do another cylinder. How about x squared plus z squared? Yeah, I like perfect squares, so why don't we do 9? Wasn't that a cylinder? It's in 3 space. Which letter's missing?
Y.
So where do you think it's centered?
Close to y-axis.
So it's going to be centered on this y-axis. And what's the radius? That'll work. I just want, when you'll notice in the notes, I wanted to just at least give you one example of that, right? The software I use to make those sketches of those cylinders, it's called WinPlot. It's free software if you want to download it yourself and look at these sketches. Because it is fun. It's kind of fun to twist it because it allows you to look inside it.